during the passing period.
Oh, you sent my school email?
I would recommend the school email. But if you already did it without the school email, it's okay. It's okay. All right, we're going to be looking at the circles a smidge more. Except now it's kicking up a notch because we're going to deal with semicircles. Semicircles. And if you started on the homework, you'll have seen we ask you to solve for upper or lower semicircles or left and right semicircles. And what that is we solve for a certain variable to get an equation for a semicircle. So we take our circle equation that we had, you know, these guys, the x. What's up? It's still 3-2. This is the end of 3-2. So we're using our circle equation. The x minus h squared plus y minus k squared equals r squared. Solve for y to get upper and lower semicircles. The upper semicircle will be when it's the positive square root of blah-bitty, blah-bitty, blah-bitty. And the lower semicircle would be the negative square root of blah-bitty, blah-bitty, blah-bitty. So remember when we square root, we usually get plus or minus? Plus gives you upper, minus gives you lower. Very similar for when we're solving for left and right semicircles, but this time we solve for x. So our left semicircle, think about a number line. Negative numbers are to the left. Positive numbers are to the right. We will practice this. But what we're going to do is solve for the variable. Solve for y or solve for x. So the first one we're going to do, once you get done with this, is x squared plus y squared equals 81. X squared plus y squared equals 81. All right. And what we're going to do is we're going to find upper and lower semicircles for x squared plus y squared equals 81. All right. So when we are solving, y'all, when we're solving for upper and lower, that means we're solving for y. So we need to get y by itself. So what am I going to do here to get y by itself? Not square root right off the bat. Subtract what? Minus x squared from both sides. We're going to have y squared equals 81 minus x squared. And that's totally fine to have it in that order, or if it bothers you to have the x squared behind, put it as negative x squared plus 81. I don't care. Then what do we do to get y by itself? Square root both sides. So we're going to have y equals plus or minus the square root of 81 minus x squared. Can I simplify that radical? Can I simplify a radical when there's adding and subtracting inside of it? No. Stop it. Leave it alone. If there's adding and subtracting inside, stop it. That is a difference of squares, not 9 minus x. Difference of squares is not a perfect square, so we cannot square root it. So when we are looking for our equations for our upper semicircle, which one's going to be the upper half? positive. Y equals the positive square root of 81 minus x squared. For our lower semicircle, lower half, what's it going to be? The negative square root of 81 minus x squared. So we solve for each variable. Upper half is positive, lower half is negative. On left and rights, left side is negative, right side's positive. But a very similar vibe. We're going to do another one, a little more complicated. We're going to do left and right semicircles. This one has parentheses. We do not need to multiply it out. Left and right semicircles means we are solving for x. We want to get x equals. What do we need to do to get x equals? Subtract what? Y minus 5 squared. From both sides. Giving us x minus 3 squared equals 4 minus the quantity y minus 5 squared. I would like x by itself, please and thank you. What do we need to do next? Square root both sides. So we're going to have x minus 3 equals plus or minus the square root of 4 minus y minus 5 squared. What do we do to get x by itself? Add 3 on both sides. So we're going to get x equals 3 plus or minus that same square root guy. You just plopping that down. 4 minus y minus 5 quantity squared. We want the equations for the left and right semicircles. So which one's going to be left?
The negative.
The negative. So x equals 3 minus the square root of that hot mess. That's what. And the right semicircle is the x equals 3 plus the square root. 4 minus y minus 5 quantity squared. So we have it like this. We can also square it back over, try and get things back together to find centers and radius, all that jazz. So we have all kinds of pieces in here. We just hadn't quite gotten to the semicircles, and I wasn't going to try and squeeze that into the last 2 minutes of Friday, because, yeah. Circulating. It's in the back. It'll come around. Okay. Questions on semicircles? Because those do show up on the homework. Those lines. That puts us up to 3-3. We can start 3-3 today. It's lines. Don't freak out. You have dealt with lines for years. Upon years. Upon years. Okay? We have dealt with lines for forever. We have 3 different forms here for the equations of lines. I don't know why equations of lines is very small. That is the title. That's the title. It played lots of formatting games. That's the title. Sometimes when I import it to my iPad, it goes, to heck with your formatting. I make my own choices. Thank you. My iPad and my Google Docs do not like to get along. They argue, and sometimes it's over formatting. So equations of lines is what we're talking about. We have 3 forms here for our equations. What is slope-intercept form? What does the M stand for? Slope. What does the B stand for? The y-intercept. We've worked with that one for forever. Yes, dear. Clipboard. What is point slope form? Do you guys remember that one? Y sub 1 equals Yep. The M is still the same M. That is our slope. The different piece on this one is that we are not given the y-intercept. We are given a random point on the line. It's a rando. X sub 1, y sub 1 is just a random point on the line. Any possible point. Did the whole row get it? You guys get it too? Okay, cool. Just making sure. Okay. So this is a random point, any point. There is nothing special about this point other than the fact that it's on your line. All right, how about general form or standard form? Yep, ax plus by equals c. This is the only one that doesn't have our slope in it. A and b should always be integers. In fact, so should c. They should always be like proper numbers, not fractions, not decimals. And a should always be positive, but I'm not going to be pedantic about that part. All right. We're going to play with lines a little bit. Which means it might be helpful to have some graphs. Shot the ball shots. All right, I'm going to find somebody somewhat decent, not chaotic, but worse. All right, so we're going to sketch them. If you want to just like sketch them in your graph without graph paper, that's totally fine. We're not going to be super specific about it right now, but if you want graph paper, it's all for you. There you go. I promise I didn't forget you back there. I promise. I just needed a couple more. Okay. So we're going to be sketching y equals mx for these slopes. We're given m. What's our y-intercept for all of these? If it's y equals mx? So for all of these lines, we have a y-intercept of 0. This one's going to be y equals 4x. This one's going to be y equals negative 2x. This one's going to be y equals 1/2 x. No b. There's nothing added on the end. So our y-intercept for all three of these is 0. If it helps you, write it in. So we're starting at our y-intercept of 0. That's an x, just so that we're clear. Looked like a y, but it was an x. So for the first one, for our y equals 4x, how do I move with that slope? Up 4, right 1. Up 4, right 1. Or I could go down 4, left 1. Down 4, left 1. And we connect them. So kind of a quick slapdash line. Not super specific, not super crazy. A line. I recommend doing all these lines on the same graph, just so we're aware. So then we're going to do the same y-intercept with a slope of negative 2. How do I get a slope of negative 2? Down 2, right 1. Down 2, right 1. Down 2, right 1. Or up 2, left 1. That's fine too. Should wind up vaguely downhill. In fact, this one looks like a really fun roller coaster. Or a really fun slide. Less of a roller coaster, more of a slide. Nice and steep. Clipboard hasn't been to the front row. All right, and then our last one on this one, we've got our slope of 1/2. How do I do a slope of 1/2? Up 1, right 2. Up 1, right 2. Up 1, right 2. As many times as we can. The more points you put, the easier it is to connect them up in a straight line. The minimum you need is 2, but the more points you draw, the easier it is to connect them with your ruler. And we made a pretty but kind of wonky start. Yes, sir. Yes, the front row's still using it. It'll come down. I'll get it over to you. Okay. So lines are vaguely familiar. We've worked with them before. Now we have a different thing. We have a point and some slopes. Yes? How many do you want? As many as you need. This bucket is also full of graphs. I just haven't gotten a chance to sort out the singles. So this time we're given a point. So we're not going to be starting with a y-intercept of 0. We're going to be starting at the point 3, 1, which is this point right here. And we could use that point slope form to write equations for these. If you like slope intercept form better, you can absolutely do that. Y minus the y value from the point, which is 1, equals our slope of m, which is 0, x minus 3. That would be the point slope form of the first equation. How do I move with a slope of 0? Is 0 a number? What is the invisible number underneath every whole number? 1. So I could also write 0 as 0 over 1. Does that help us figure out the slope? How do we move? Up 0 over 1. So we're going to go up 0 over 1. Up 0 over 1. Up 0 over 1. What does this look like? A horizontal line. Horizontal lines have a slope of 0. What is the slope on a vertical line? Not infinite. Can we have a slope of a vertical line? No, because that's just up over, like divided by 0. It's called undefined. What's up? Tape, yeah. I also have more glue sticks if you just need a different glue stick. What's up? But I started at the point 3-1. I mean, let's put at this point. So we're using this slope and this point for all of these lines. So we're going to do the same thing for the next one. It's still going through this bright pink point. This bright pink point is going to be our home base for all 3 of these lines. So we're going to have y minus the y bound from the point 1 equals this one. We're going to use our slope of 2. X minus 3. Still goes through that point. So this is that point slope form. If you'd like to, you can switch this around and solve it into slope intercept form. Or we can go, I know it goes through this point. How do I move with the slope of 2 from this point? Up 2, right 1. Up 2, right 1. Up 2, right 1. I can still just do that from the random point. Up 2, right 1. Up 2, right 1. Up 2, right 1. Like that. So we can use the rando point for that. And still get our line. If you were to solve this around, you would find out that our y-intercept is going to be -4, which is exactly where we hit, if we graphed it carefully. One more like this, where I'm going to take my point, that same point, y minus the y value from the point, 1, equals our slope, which I'm going to use green, of -1/5 x minus 3. And again, you could multiply this through and put it in slope-intercept form. Honestly, I think that's the hardest way to do it, is to multiply it out. I'm going to take my random point that we're starting at, this hot pink point. How do I move with my slope? Down 1, right 5. Down 1, right 5. 1, 2, 3, 4, 5. Or I could go up 1, left 5. And we can see that my y-intercept is going to be gross. I believe it's about 2/5 or 3/5 or somewhere around there. One and 2/5. So the point slope form, it's sometimes just easiest to take it as it is and take the point out of the point slope form and work with it there. questions on our point slope form for that guy right there? We're going to do one more graph. Now I have 3 entirely separate equations. One in each form. And those are all very small and very gray. But that's okay. Let me still read them in the background. So graph all 3 of these. Sorry, while you do that, I need to mark our attendance because I didn't actually get that done yet. Okay, so this first one is slope-intercept form. We love it, classic. We started our y-intercept of 1, we move with a slope of 2. We get a line that looks like this. We love slope-intercept form, classic. Working with it forever, very comfortable. In standard form, you have a couple of options. You can either solve it in a slope-intercept form and keep on trucking. You can do x, y intercepts where you substitute in 0 for x to get your y-intercept, substitute in 0 for y to get your x-intercept. Or you can kind of do a guess and check point situation where you pick an x, plug it in, and get points that way. I have a tendency to go my slope-intercept form, or to go with, solve to slope-intercept form. But it's not wrong to do x, y intercepts. So to get this one in slope-intercept form, we're going to subtract 2x from both sides. Minus 5y equals minus 2x plus 8. So gross. And we get our slope-intercept form of y equals 2/5 x plus 8/5, or 1 3/5, right? Yeah. Which is gross. 8/5 would be fine. Yeah, it leaves us with 1 3/5. Where'd I get the minus 5? Oh, it would be negative. You're right. It would be negative. We divided both sides by negative 5. So it would be 8 over negative 5, or negative 1 3/5. Oop, sorry. Which negative 1 3/5 is gross and here-ish. Which we can absolutely go up to and over 5. 1, 2, 3, 4, 5, and put it there-ish. That's fine. We're getting it close. These are not going to be perfect. We could also plug in and get x-intercepts and y-intercepts. Y-intercept, we have x-intercept. Happens when y is 0. We'll get an x-intercept of 4, which is exactly where we hit anyway. We got pretty dang close. So it's not pretty, but it's doable. And our bottom one, we're going to grab our random point from inside this point slope form. Remember, it's y. Ooh, that's not a pen. Y minus y1 equals 1/2 x minus x1. So what is the x1 value? -1. What is my y value? y1? +2. So this is starting at the point -1, +2. What's my slope? 1/2. Up 1 over 2. Up 1 over 2. And we're going to equations that look like that. So sketching the graph, we don't have to like make ritualistically perfect. We're just getting it pretty dang close. So if it says sketch, we get as close as we can without stressing about it. Okay. We're going to remember how to do slope. We've talked about it. It's come up before, like we've seen it previously this semester. Finding our slope. That's when we have the change in our y's over the change in our x's. Those of you that did physics have seen it that way before. Or where we take my y2 minus y1 over x2 minus x1. That's the more algebraic way we write it. And this is how we find our slope when we're given 2 points. So I've got 2 points here, C and D. Let's find the slope between them. Our slope is, we're going to take our y values and find the difference there. So my y values are -7 and -3. We find the difference. My denominator is the x values. -9 minus, that's 2. You're right. Yep, I just caught that myself. -7 minus 2. 9 minus -3. Totally just making sure we're paying attention. Totally. Haven't done that at all day today. Putting things in the wrong spot. My brain has not booted back up from the weekend. So we simplify this. -7 minus 2 gives us -9. -9 minus -3 gives us -6. -9 over -6 simplifies down to what? 3/2. So then we got to remember the relationships between parallel lines and perpendicular lines, which again, we've already talked about once. We talked about that with our triangles and our square stuff that we did a minute ago. Parallel lines have the same slope. So if we wanted to set a parallel line to this one, it would need to have the same slope. And a perpendicular line has the opposite reciprocal. So what would be a slope perpendicular to 3/2? -2/3. The more like algebraic concept is that they are inverses of each other. They multiply to make -1. They're multiplicative inverses. But opposite reciprocal is way easier to remember. Okay, we're going to practice with this a little bit. So we are going to write a general form equation that meets these conditions. Yes, I can go back. So our first one is that it is unreadable to my screen. 5, -2, and parallel to the y-axis. So it goes through that point and is parallel to the y-axis. See if you can do that. Goes through the point 5, -2, and is parallel to the y-axis. You won't need to graph it, but yes, I do. Yep. I have as many as you need. I also have, if you look at the paper tray over there, the very bottom one has a sheet that has 6 graphs on each side. Okay. So we're going to write a general form equation that goes through point A and satisfies the condition. So if it is parallel to the y-axis and goes through the point 5, -2, which is here-ish, what's that line going to look like? Vertical. How do I write the equation for a vertical line? X equals. What is our x going to equal? 5. Because it's got to go through that pink point. Through 5, -2. So it goes through this one and it is parallel to that y-axis, which means it's a vertical line. So sometimes giving yourself a little sketch, not a graph, a little sketch, helps us see it. A sketch never hurts. So then we're going to do, it's very similar, but we're going for perpendicular. So we're going through 5, -2 again, but this time we're going for perpendicular to the y-axis. What's that going to look like? A horizontal line. If it's perpendicular, that means it meets my y-axis at a right angle. So how can I write that equation? Is it x equals? Y equals, what was it? -2. And then the last one here is point slope form. So all we need to do is write an equation here in point slope form and then multiply some things out. So we're going to take our y minus the y value of my point, which is -2, equals our slope of -4 times x minus 5. But to get it in general form, it means we need to have no parentheses, my x and y on the same side. So how do we get this into general form? Distribute. So we have y plus 2 equals -4x plus 20. I need my x and y on the same side. So what are we going to do? I want x and y together. So let's add 4x. We're going to have 4x plus y plus 2 equals 20. And subtract 2. Because I want my x and y's together and the numbers all on the other side. So 4x plus y equals 18. And that's our general form. Okay, everything else on the homework for 3-3 we've actually done. Because it talks about the rectangle thing again, like we did that with the points, finding our distance formula, see if things are right angled, see if they're perpendicular, all that jazz. Our first quiz for this chapter is on the 21st, which is Thursday. It's Thursday. This Thursday. It's up to this stuff with the lines. Please make sure you got to the clipboard before you leave. It is in the front over there by the couch by Lincoln. It's got a horse on it. I got these like 3 years ago. It's just relevant now. Wait a second, it's the Barbie! Mojo Dojo Casa House! But it's a Mojo Dojo Casa Pen.
None of those
Okay, you got to see Barbie.
could not just understand what just happened.
Uh-huh.
It doesn't have like numbers on it, but it's like it's rain or something.
Yeah.
So what I just like write it out like
That's what I thought.
Yeah, it's fine.
Just like
I think that would
The Barbie.
spooky.
Really old. Huh?
What did you say?
Mojo Dojo Casa Pen.
Okay,
Because it's the Mojo Dojo Casa House.
you said that's from Barbie.
It's from Barbie.
Like the new movie.
Yes. It is actually worth it.
Okay. I mean, I know all the old ones,
No, this is,
but
it is worth it. It's good. They did it well. It's
Okay.
not, it doesn't make you hurt.
Have you heard?
As a feminist, it does not make you hurt. No, it's good. Like, there were people that legitimately cried in good ways.
I mean, if I see all the alpha males complaining about it, it probably means it's a good one.
Mm-hmm. And what that is Ken takes over and instills patriarchy
Oh,
and
not fun.
into Barbie Land.
Ken,
And so it's no longer the Barbie Dream House. It's Ken's Mojo Dojo Casa House. And it's all horse and cowboy themed.
Ken's stupid.
He's a horse girl. He's a horse girl. And so he calls it the Mojo Dojo Casa House instead of the Barbie Dream House.
Ken's always been.